my digital pathology trailblazers. This is a recording of a webinar I hosted today. And thank you so much for showing live. So many of you have shown live. But I know that not everybody was able to. And I know that my podcast listening digital pathology trailblazers are not always the same one that are looking at the videos. So that's why I wanted to give you the opportunity to listen to this as well. So let's dive into it.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Aleks Zuraw.
Welcome, everyone. Thank you so much for joining me live. I see already people joining. So whenever you join the live stream, the live webinar, let me know in the comments, where are you tuning in from? We are a little bit early, maybe 1 minute early. So there's going to be enough time for everybody to join. And I'm looking forward to hearing, where are you dialing in from? I'm in Fairfield, Pennsylvania, population of 500, talking to you about AI and machine learning in pathology today. Hi, Christian. Great to have you. Let me know where you're dialing in from. Today's topic is I hope it's gonna spark some discussion, because it isn't really, but it can be controversial. And we have Fabio from Brazil. Welcome, Fabio. Great to have you here again. Amazing. From Brazil. What time is it in Brazil? I assume. So it's 9 a.m. in Pennsylvania. Let me know what time it is where you guys are. But great to have you here. So let me tell you. Welcome, France. Ali, hi. Hello, Germany. We have Cape Town. Hi, Brendan. How are you? Okay, it's 10 a.m. in Fortaleza. Thank you, Fabio. We have Atlanta, Georgia. Amazing. We have Johannesburg, South Africa. This is so cool. It's great to have you here, everyone. Hi, Krzysztof, and good afternoon to LinkedIn. So we are live on LinkedIn, on Facebook, and on YouTube for sure. So also let me know, which platform are you using? Is it YouTube? Do a Y for YouTube and L for LinkedIn, or the first letter of whatever it is that you are watching at. Good morning, Fernando. Good morning, Stacy. Amazing to have you here. USA. We have Sweden. Mari, welcome. Okay, we have YouTube, we have LinkedIn. Perfect. And some of you may be just dialing in from a direct StreamYard link. Whatever you're using and whatever works for you is amazing. Hello, Denmark. Why do I say that this topic actually is why is this topic controversial? Why would it be controversial? So because I think it's very polarizing, and all the polarizing topics are controversial. So when I published my last video that you might have gotten in the mail, this was AI in pathology. And this is the thumbnail of the video on YouTube. And surprisingly enough, not too many people have watched this. I think we're going to have more people watching this live stream than the video, but that's okay. I just wanted it to be out there. And I got some emails, I got some comments. For example, one comment was, AI can be used for prostate and breast core biopsy. It's helping, but it's not absolute. And then the other comment was, what is the role of pathologists if AI is being used? Like, there is this role of pathologist is being questioned when in the context of AI being helping pathologists, replacing pathologists. Where do we stand on that, right? Other comments that I've gotten was that predicting molecular status is very random. The person didn't trust predicting molecular status. And then there was another one that the real utility of AI is just to filter out the negative cases. So a couple of comments, couple of opinions. If you have your opinions, comments, things that you think right now about AI, let me know in the chat. Like, the first thing that comes to your mind, AI and pathology, why did you join? I assume you're enthusiastic about it. That's why you joined, but maybe you have some concerns. Maybe there are ethical concerns. Maybe there is job security, maybe the reliability of this, or maybe you're super excited that it's going to streamline work. And we are going to touch on all of these. And my first reaction to the comments was, let me tell you, it was defensive. I'm like, how do you mean it's only useful for negative cases? There are so many other applications that it can be used for. Why do you think this predicting of molecular status is random? When is it random? Have you not seen this publication, that publication? And then I kind of took a step back. Basically, they depending how you look at it, is they can all be true and they can all be false. Why? Because, now let me show you a few more. For example, it's all about validation. Actually, only as good as the validator. So it cannot be better than the validator. And the validator is a person, so it's actually fallible, like makes mistakes because we make mistakes. And then, okay, are we really there yet? Can we use it? Are we like, no, let's not use it? So this kind of comment. Don't leave me. If I accidentally end this stream, then no, I didn't end the stream. Then just stay. Logistics here. Whenever something goes wrong, just wait for me. I'm going to try to troubleshoot. And if my internet goes down, I have my phone. I can use my phone data. So don't leave me. We're just starting. And I just want to welcome Belgium, Masoud. Hello. We have Nigeria and we have London. Amazing. Thank you so much for joining. So we're going to start with what AI is. Because as I told you, I have my super thing to write. Let's see if I'm better than last time. What is AI? Because, okay, I am getting ahead of myself. Let me go through the agenda for you. What is machine learning? We're going to talk about narrow versus general versus super AI. Super AI. Who wouldn't want super AI? Well, not everybody would like super AI. Then we're going to talk about some AI applications in pathology divided by AI branch. You're gonna know what that is in a second. And then application divided by area of use. And then we're gonna talk about AI to computer vision translation, not because I want you to learn AI to computer vision translation, but this is kind of an example of a translation that we need to learn to be able to leverage those tools or discard those tools or do whatever we want with these tools. So let's start with, what is AI? What is AI? What is AI? It is a term used to describe machines that can perform tasks that normally require human intelligence. So what can we use it for? We can use it for visual perception. We have cameras that recognize faces, everything. We can use it for speech recognition, decision making, whether that's totally ethical or not. That's a topic for another discussion. And by the way, I did give a presentation on ethics in AI at some point. So if you would like to have me present this to you and talk about this in one of our future webinars, let me know in the comments. Just write ethics and I will know that you want it, and we're going to have this conversation as well. And I'm going to make sure that we have enough time for discussion, because this is also like a non-black and white topic that will require discussion. Language translation. I love languages. I speak like 6 or 7, but you know what? If I didn't, I could get by everywhere. Or now, because now with my phone, I can just basically take Google Translate or any other translate, ChatGPT Translate, and go and be happy across the world. So that's what we're going to be talking about today. AI. So also another comment to what is AI, because I often hear, and I kind of like teased it in the email about the video, that, oh, I would love to use AI in my pathology work. So maybe I don't know in which year, but maybe it was just connected to one thing. When I was starting, it was just image analysis. When somebody was talking about using AI, they wanted to do image analysis. Now, when I hear this statement, it's like, I would like to use AI in, I don't know, in anything. To me, it's like, I would like to use a machine, but what kind of machine? What do you want to use it for? Well, I would like to use a machine in my kitchen. Okay, that's still not specific enough. So we need to be more specific, or, I mean, we don't need to. But if we want to communicate and we want to engage in the discussion and not generalize and not discard, or how do you say that? Not in Polish, you like spill the kid with the water. Write me in the comments what's the correct English version of this idiom to like get rid of the baby with the bathwater, right? Because if we just have this categorical opinion or preconception about AI, I mean, we might be as right as we might be wrong, and there's a lot of nuances to this. So that's kind of my general goal with this presentation today. So the next question that we would like to answer is, what is machine learning? You can also hear, I'd like to use machine learning for my pathology work. Yeah, I'd like to use machine learning. And to me, whenever the first thing I think about when I hear this is image analysis. Because I'm biased, because I started in the image analysis field. To me, always AI is image analysis. But now we know it's a lot more for a lot more things than just image analysis. But nevertheless, every time I hear this AI and machine learning, when I hear machine learning, I'm thinking random forest. And I'm thinking, don't use it. It doesn't work for pathology, which is exactly a statement that is as incorrect as correct. I've seen enough images enough images analyzed with random forest that didn't match the tissue, but there were others that were good, and random forest is good for other stuff maybe, and not necessarily for tissue image analysis, or it's maybe good for tumor stroma separation, but not cellular analysis and things like that. So me saying, oh no, scratch this random forest, go and do everything with deep learning. It's like, well, yes and no. You're right, but you're not really right. So anyway, going back to our presentation and I see some of you wanting the ethics presentation. Fantastic, Luca, thank you. Whoever wants the ethics presentation, let me know. If there is some of you that want that, I'm gonna organize that. Basically, I'm gonna give you the presentation updated, because every time I prepare a presentation, I think that I already have everything. I don't have it because I need to update. So the crucial thing is here, subfield of AI. What did I use right now? I want this one. Subfield. So what can it be used for? And this subfield, you can create models that let machines perform tasks that would otherwise be possible for only be possible for humans. It's like, okay, Alex, are you repeating the same definition? Here it was also normally would require human intelligence. Well, because it's subfield, and it's pretty broad subfield, it can also be used for categorizing images, social media optimization. So the feed that is being shown, for example, on LinkedIn, it's based on your preferences. It's updated by AI while you're scrolling, and it's learning what you like. So in my feed, I have 99.9% digital pathology content, or like digital health content, mostly digital pathology. So LinkedIn knows my preferences. Mobile voice to text and predictive text, price fluctuations, all kinds of predictions, facial recognition, and product recommendations. So this is machine learning. And basically, when it's being used in the context of AI, of pathology, machine learning is such a huge subfield of AI that it kind of is being used interchangeably. In theory, and to be very correct, when we look at this diagram, AI is the biggest circle of the computer science. Then inside of AI, we have machine learning, and then even more inside is deep learning. And deep learning, this is from the book. By the way, we are talking about chapter 3 of the book. And if you don't have the book yet, at the end of the presentation, I'm going to have a QR code so that you can download the book. But basically, now, deep learning is pretty popular, but it's not exclusively what's being used. I have seen, and I'm seeing, a combination of deep learning and classical computer vision and classical, image analysis. I'm going back to image analysis. It's not only image analysis. Anyway, deep learning is like a well-performing way of doing AI. And spoiler alert, we're not going to be talking exactly about the building blocks of AI. We're going to be talking about concepts today. So anyway, just to summarize, AI versus machine learning versus deep learning, now very often they're used interchangeably. Correctly, incorrectly, I think now everybody more or less knows and assumes that when we're talking about AI, we're talking deep learning or a combination of deep learning with something else. So that's what this is. Yes, and I'm getting good comments about generative AI that can have many applications. We're going to be talking about applications, and it's not exhaustive what I'm going to be telling you about. There are probably more applications than we're going to be talking about, but we're going to talk about categories that will help you navigate what AI can be used. And I hope that's going to be useful. So let's talk about narrow AI versus general AI versus super AI. So narrow AI is also known weak AI. My friends, it's very weak. This AI is supposed to be so powerful and is weak. It is the most common type of AI. I want you to remember this, because this kind of, I can even the fact that this is the most common type of AI, and some people, including truly yours, Dr. Aleks Zuraw, would say this is the only type of AI that we have. It's only doing some limited specific tasks or a range of tasks, a specific task or a range of tasks. So facial recognition is a specific task, right? Then speech recognition is a specific task. We have image recognition. We have natural language processing, which these two are related, speech recognition and natural language processing. And then recommendation systems. Whenever I go on Amazon, my Amazon miraculously knows what is the next thing I want to buy, be it, whatever, workout equipment or clothes or whatever. It suggests me those super cool things. And this is based on AI. So narrow AI, right? Let's remember narrow AI is the most common type. What do we have next? We have general AI. Make it big. General AI. This one would be strong. And you already hear me saying it would be, is designed to perform any intellectual task that the human could do. So if we go here, we have the narrow that can do facial recognition, then another one can do speech recognition, then another image recognition. Like I can do it all at once, right? So the general, if there would be a general one, it could do it all at once. And here, the thing here is it is a theoretical form of AI that is not yet possible to achieve. It's a theoretical form of AI that is not yet possible to achieve. This is like the scientific classification of these AI capabilities. And, you can Google it and there's plenty of references. The reference I used was an article on LinkedIn by Professor Ahmed Banafa. And yeah, so what would this AI be able to do? It would be able to reason, to learn. It would be able to understand complex concepts just like us. It would be our AI robot friend. Wouldn't that be great? Well, maybe yes, maybe not, right? So this is general AI, and this is a theoretical concept. And now I'm surprised I'm not getting any comments telling me that, hey, Aleks, what about ChatGPT? Is that not general AI? They say it's general, right? It can understand like all this text and you can talk to it and it talks back and all the other large language models. Well, let me tell you, it can understand text, but it's just a chatbot. It uses natural language processing and generative AI. And we had a comment about generative AI. So generative AI is basically AI that can create something from scratch. Based on some training, it not only predicts something, but it actually creates. So this one creates text, and there are other creations that AI can do. But it's just for conversations, right? So it can only do one thing. It's very, very good at this one thing. So to me, this is still narrow AI. And I totally agree with this classification. We are in the world, in the reality of narrow AI. We can stack several narrow AIs to have a pretty powerful tool, but it has these narrow AI components. There's always going to be something that's missing. Like, I don't know, can it recognize the flavor of my tea? Is there a model for that? Would you even want a model for that? I don't think so. So, ChatGPT, narrow AI. Aleks, what about DALL-E? DALL-E can make images, but you already know where I'm getting at, right? DALL-E can make images, but, well, it actually, look, it's powerful. It actually does text to image. So, text to image, it can generate generate images from prompts, from text. I'm going to show you something funny later, because this tool that I'm using for these presentations, it is AI powered, AI enabled. So what does it do? It has a language model that generates some text. So if I put some concepts, it's going to put it in nicer words. It can actually generate images. So several of those images are being generated. If you don't have a citation, or if it's not from a paper that's cited, assume that this is an AI generated. And then, yeah, it's not that as you would think. I'll show you. And hello to Vet Candy. So anyway, DALL-E, it can do text and image, text to image. It doesn't do image to text, but now you can combine these things, and we're going to be talking about this, and you have more powerful use cases, but still narrow AI. And Berlin is here. Hello. And let me know if you want the ethics presentation. I am getting some more ethics yeses. And also, if something comes up for you when I'm saying, oh, this is this way, this is that way, drop me a counter argument or a counter example in the comments. I'm going to be starring these so that we can talk about this in the Q&A. So here, I hope I convinced you that we are in the era of narrow AI, but still when we talk about AI, I want to use AI. It's like, I want to use a machine. Okay, what for? What kind of AI? What about super AI? Super AI is super. It's better than us. It's does everything. It's capable of surpassing human intelligence in all areas, Basically, it can solve climate change, eliminate disease and poverty, and the examples are Terminator. Literally, there was a reference because, so let's go back to something that I skipped. It is a hypothetical form of AI. This one was theoretical, so I assume theoretical is closer to reality than hypothetical. So that's why Terminator. There was another Iron Man and some other examples in giving this example. So, but actually, the development of super AI is the ultimate goal of AI research. Do we want that? I'm going to confess something. I actually never watched Terminator. There are a couple of movies somebody recommended, and if you have any recommendations, let me know in the comment about AI. There was one positive one, and one Terminator was not so positive. Although I didn't watch it, I will watch it next time, and I report if I did. But yeah, from common knowledge, I assume Terminator was a robot that went wrong, but then he was good. Anyway, doesn't matter. Digressing. So super AI, not there. Hypothetical form of AI that's going to be even better than human, but we're not even close, right? Which is fine, So thank you, Professor Ahmed, for those nice definitions that I used in our presentation. And let's talk about applications, AI applications in pathology. We're going to start with AI by branch. And by branch, I mean by like the area of computer science is being used. So as you all know, and we'll hear several times, I started in the image analysis field. And this is what, for the longest time, AI in pathology was used before the language models were even considered to be incorporated. I have a good recommendation. I should watch Moonfall. Okay, I'm starring this recommendation, Dr. Kim. So yeah, by branch, image analysis, then natural language processing. We already started talking about this, and we can combine the two right now, right? And at the moment, this is like the state of knowledge that I have, state of research that I have done for you. It doesn't mean that, next month there's not going to be a new application. So obviously, if you're interested in that, LinkedIn is going to give you the correct feed if you're liking and engaging with the posts about these topics, about this subject. But yeah, so it doesn't really matter how current this information is. It gives a framework to see what kind of AI is out there and how can we use it and what the applications are. So AI for image analysis, it also has several applications. Oh, and I have a great recommendation, another one. I have heard about this movie, Her, but I haven't watched it. So homework for me, watch the AI-related movies to be able to reference some pop culture references and not just papers. My sister is so good at this. I am not good at pop culture. Anyway, so image analysis can be used for different things as well. And the beginning was, of course, quantification. We were able to quantify. So these are Alzheimer plaques, and these are my personal annotations in a specific field of view where I wanted to annotate them. And they are both counted and they are delineated. So here's the delineation. The dots are for counting. Basically, they are quantified in one way or another. Here, this tumor is being delineated as well. Once it's being delineated, you can calculate the size. You can do different things with it. And if you want to be even more granular, here I was not that granular, that you can separate this stroma from the tumor epithelium. And here you have this that is exactly delineating. So if, for example, the amount of stroma, which I know in pancreatic cancer that is the case, is a kind of biomarker, then you can exactly quantify and do your calculations with these quantifications, with these numbers. We can use image analysis for computer-aided diagnosis. And go ahead, if something comes up for you like, yes, no, I'm afraid, let me know in the comments. Just let's have a base for the discussion later. So computer-aided diagnosis. I have noticed in around 2019 that there has been a shift, the concept, especially in the image analysis world and AI for pathology world, which at that time was focusing on image analysis, that there was a shift from this concept, AI is going to replace pathologists, which I am not saying that this concept is eradicated, because this is something that comes up very often when people start learning about this and do not have yet granular information, nor do they have information how these tools are being developed. So before 2019, and this is my arbitrary date when I went to conferences, the paradigm started shifting. Then before it was AI is going to replace pathologists and you will not have to look at things. It's going to diagnose for you. I assume people actually hope for that level of performance, regardless whether, the ethics questions and if we want that and if it's legal. I think they were hoping for that level of performance. And very quickly with deep learning, when deep learning entered the scene, AlexNet was outperforming everything in image classification competitions. They thought, okay, everything that's image-based will no longer need to be done by pathologists, by doctor, right? And very quickly, while working with pathology images, the scientists realized, well, it's not like one thing takes care of all. It's still narrow, and when it comes to diagnostics, it's even more narrow, because for every entity you actually need an algorithm if you wanted to go the diagnostic route. Nevertheless, so the paradigm shifted to something called computer aided diagnostics, not computer diagnostics, but computer aided diagnostics, where a pathologist is using AI as help. In 2021, we had the first FDA cleared solution for this computer aided diagnostics based on image analysis, deep learning, September 2021. And who did that? I bet we all know who did that. That was Page AI, and the algorithm was called Page Prostate. So they went to the FDA with their solution, saying and showing data backing up that this is a good help for pathologists. And from what I remember, it was that pathologists with AI were 7% better in whatever their metrics were. And, you would have to go back to the paper, which I don't have cited here. I'm going to do this after the presentation. But basically, they were 7 percentage point better than pathologists alone and then AI alone. So the combination was better in detection. And here also keyword detection of malignant foci. And this is the task of this detection of foci that are suspicious of malignancy, and they are being highlighted to the pathologist. That's the only thing that this algorithm can do. This particular one that got the clearance. Can you go even more narrow than that? Maybe you can, but this is not specific to this one, right? This I don't mean it in a negative way. This is what we're dealing with in pathology. So then also like prioritization of this algorithm development is going to be by the number of cases per year, by the number of slides pathologists have to review per year. So it's not going to be, let's now, although there's a concept called foundational models where they are developing models that can recognize more general things than just particular cancer, like in this case. But that's outside of the scope of this presentation. So that was 2021, and we had computer-aided diagnostic application. So that is the only model that was actually authorized by the FDA. Does that mean that that's the only one out there? Not at all. Not at all. There is a publication. It's actually preprint from this from the where is the publication? Here, the reference is here. Anyway, it's a preprint, but there is public evidence on AI products for digital pathology. It's a very interesting publication that, let me show you everything I have from it, and then I'm going to comment on that. Very interesting publication showing that all the different things that are being used, and I found this figure, it's part C of figure 2, actually. So we have our Page Prostate, right? And when you look at these arrows, date of first publication, prostate published here, and then got approved here. This is like a stellar example. They published first, and then their data was so strong then that they got this approval, right? And here blue is publication prior to approval. The DX prostate, there is approval. Where's the publication? I don't see any publication. Ibex Galen prostate. We had the approval. Where's the publication? The publication is post-approval. And then there is Page prostate grade and quantity. So they are adding on top of the Page prostate that only detects, they are adding the grade and quantity. Approval, here is the publication. And it doesn't mean approval by FDA, because these are also European companies or different country companies. And I'm sorry, because I didn't put it big. I'm sorry, this should be big. Let me know if I'm doing the wrong view. Please let me know so that you can actually see what I'm drawing on this drawing board. So anyway, this is from across the world. This is from 2019 to 2023. And this paper, the public evidence on AI products of digital pathology, this paper gives like a list and breaks them down. There is a lot of those used tools that are never had any approval or never had any publication. They were developed. I assume somebody did some kind of validation in the lab where they are using this tool. I definitely would, but over 100 publications. So here they're only showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12, 15, right? 15 publications, 15 tools here that actually got some kind of approval. So they all have a dot. Dot is the approval. And whether the publication was before or after, I think there's only one that doesn't have a publication. All the other ones have publications, which is great. Some were after them before. Anyway, there is enough proof for regulatory bodies for these particular tools to go validate on your own as well, and because that's probably a requirement of every lab, and use them. But this is just 15, and in the publication there's there's over 100, at least 100, more than 100. I'm guessing 123. Who's using that? I guess you can just use it if you want to. I know one particular practice that is very much using it and has been using it for several years. This is a practice in Puerto Rico, Core Plus. Core Plus is run. What I wanted to show you is all the partners that they have, that they are working with. Alpenglow Biosciences. Here is TechSite. This is a webinar they had with TechSite. And Core Plus partners with Alpenglow. And this is Mariano de Socares, the CEO of this practice. And by the way, I will have him on the podcast. I actually already recorded, so stay tuned for this episode. It's really interesting. But you get the point. They have partnerships with different companies. They're very, very early adopters. And they have been using it. They have been using it for several years. They have been doing their own validations, and they have been gaining confidence. How good is this particular algorithm that we're using for the use case that we have? So they did it in the CLIA regulatory framework as a lab developed test for several of these tests, including prostate, not from Page. It's from another company. Why can't I change my slide? Come on. Okay. So AI for molecular predictions. We're still talking image analysis. And here there's skepticism. And let me tell you, until I have seen this publication that I already talked about last time, and I have more images from this publication. I talked about this artificial intelligence molecular analysis tool assists in rapid treatment decision in lung cancer, a case report. Until I actually have seen this case report by Dr. Barlitz Weissengren, I was skeptical. I thought it was a hype. I thought, well, okay, nice, academic work, but when is it gonna make any impact? Because the claims were, well, this can then help those who don't have access to molecular tools because it's in the under-resourced countries that there's no access to that, right? So if we have those image-based diagnostics, then we kind of solve the problem. Well, I was skeptical. And for some application of these molecular predictions, like, for example, virtual immunohistochemistry stains, depending on the stain, I am still skeptical. But when I saw this publication, I was very, very happy. They had a way of actually checking if this prediction is okay. So what happened here, they basically did a histopath evaluation of a sample, and then they ran this algorithm to detect, the algorithm predicted the EGFR mutation. And here is this is the area where it's, and then the pathologist looked at it and said, yeah, that makes sense. This is cancer. It can have the mutation there. And they didn't blindly just move with treatment. They confirmed it with another method, which was they had this direct assay. This was a rapid PCR direct assay for EGFR. And they checked, is this really EGFR in that particular spot? And the answer was yes. And here you can see, so this is routine practice. What would they have done? They would have started the radiation therapy already. Then they would have waited 7 to 14 days for a next gene sequencing report. And then only after those, for lucky, a week, and if we're not that lucky, after 2 weeks, they would start a targeted treatment. Whereas here, they already knew it's EGFR, we can start treating. And this was based on, I want to give a shout out to this company. Let me see if I have it on the previous slide. I think it was Imagine. You can confirm that in this publication. And it was a commercially available algorithm. It was a commercially available algorithm validated for that particular lab in Israel. And it is a case report, right? So we are all have read enough scientific papers that we know that the case report is the like lowest level of evidence, and it's not a randomized clinical trial or whatever the highest level of evidence is. And so with all that in mind, I'm still excited about the potential of molecular predictions. Can I give a blanket statement that molecular predictions work? No, it's a prediction for EGFR mutation in lung cancer. That's even more narrow than the prostate. Yeah, because now you go molecular. So you predict a particular mutation. There it was malignant cells in this cancer. So anyway, I'm excited. Let me know what you think about that. This is image analysis. What else do we have? Oh, we do have applications of natural language processing. And natural language processing and this beautiful AI generated image. And wait for the semi-joke that I have for you. It's going to come soon. But basically, this beautiful image was generated by this presentation software. When I said somebody talking to the microphone, I think they have like a hybrid microphone and interesting glasses as well. But the point of the slide is we can now, with natural language processing, we can leverage the capability for speech to text for dictation that is going to be transcribed immediately. So now several of these transcription software that are powered by AI, they can be trained to the particular pathologist's voice. Several of the digital pathology or even a pathology lab or pathology softwares that you use for reporting, they have this integrated, and it gets better and better. When I was doing my residency, my supervisor was dictating everything, and then there was a transcriptionist transcribing all this, and he spoke a lot. And then sometimes so he was like very descriptive in all this, and she was always so tired when he was diagnosing. And then sometimes another person when he was not available, another person was doing this, and this other person was so much shorter and so much concise. And I remember this transcriptionist going home like an hour earlier a lot earlier, because she didn't have this first person who was very descriptive in everything. So now you don't need a transcriptionist. Speech to text is good enough, or at least there are some instances of speech to text programs that are good enough that you can eliminate the transcriptionist. Now, look at this. So the example here is we're still talking about natural language processing, structured reports, right? So just look at this beautiful structured report. The prompt that I gave is text report. I am wondering about AI myself sometimes. So this is the other prompt I get was pathology report with text, and I got some car. So you know what? We need to verify sometimes. I just wanted to show you that this was the output of the AI today, or whenever I was preparing this presentation. But structure report, so building on the story about the transcriptionist going home earlier when the other person was dictating, the more concise. How about we don't have the differences between people actually dictating a lot or dictating not that much, because we can simplify it by structured reports. And you know what? We can even simplify it more by having AI fill the report. So basically, you can dictate however you would dictate. If you are a person of many words or few words, it doesn't matter. Your expertise is being conveyed in those words, and then you have AI working on a structured report. I do not have a concrete example here. I don't know a company that actually does it, but I know the technology is there, and I know that at least one company is working with a sound system company to actually enable the speech to text and voice navigation of the whole software. That's the natural language processing. Smart search based on retrieval augmented generation. What is that? So sometimes we, or also pathologists, look at that poster. It's about pathologists and chatbots by Andrew Bitchkoff. Go to ChatGPT or any language model, and they ask questions. They kind of Google the chatbot instead of going to a search engine. And we all know that not always those answers are reliable, like we saw with my flowers. They're not always reliable. How can we make them more reliable? How can we leverage this chatbot for search, where the technology or the method is called RAG, Retrieval Augmented Generation. What is that? Let's start with smart search. Smart search is when you, for example, have a database and you search in this database for healthcare institution. in a pharmaceutical company, in biotech company, wherever, right? But you have this search. It's powered by generative AI. That's why it's called the generation. So it's not just like it's not this Word document search where it highlights the words, but it actually synthesizes an answer for you based on search in this particular database. So we kind of mitigate this or minimize or address the risk of the hallucinations of those models because we restrict the generation of new content to a certain database that is within an institution. It is hopefully curated and it's controlled and prepared. And then we also make the model reference where it took the information from. And I'm going to show you something here. I go to my other slides at the beginning. Here, let me show you something. I don't know if I have it, but there is an option in this software, actually, like find a reference for what I'm telling you about. So it has this, let's see if I can show you on. No, because I'm in a, but basically I write something, let's say narrow AI is only used for one particular task. And then I have an option to click and find reference. And it's going to find me a reference and it's going to show this reference at the particular citation where it actually claims what I wrote. So how cool is that for any type of referenced material preparation? I like it very much. If we think of the combination of image analysis and natural language processing, then I found a paper from 2023 that used medical Twitter. So what happened in this publication? There was they used crowd platforms to curate OpenPath. And OpenPath, let me make it big. OpenPath is a data set of 200,000 pathology images and paired with their natural language descriptions. If you're part of the Path Twitter or Med Twitter hashtag, I assume that's the hashtag, then you will see that there's a lot of diagnostic discussions going on there. So they basically leveraged this database and created LIP, pathology language image pre-training multimodal artificial intelligence. So yeah, the combination of image analysis and natural language processing is happening already. And let's look at it at our AI from a slightly different perspective. This was by method, and now it's going to be by area of use. And I'm aware that not everybody can stay for the full 1 hour and a half. I'm almost done with this part, 5 out of 7 topics covered. At 10, which is in 2 minutes, so maybe I will go over time 5 minutes, we're going to have Q&A session. Regarding by area of use, we can use it for workflow optimization, we can use it for research, and we can use it for diagnostics. And I think this application causes the most controversy because this basically kind of implies that, oh, now we have an automatic tool instead of a doctor making medical decisions or helping with medical decisions. What's with confirmation bias? So even if this tool is so great, but at some point it's not going to perform that well, the pathologist is going to look for confirmation. This is how we're wired. So this is the kind of controversial part. But I would love to have AI for workflow optimization. I would love to leverage it in research, assuming it performs relatively well. And for workflow optimization, what can we use it for? Automated slide QC, speech to text, we already mentioned that. The research RAG is something that could be leveraged very much, especially in the pharmaceutical industry. Let me make it big again. In the pharmaceutical industry, where a lot of data is siloed and the search of these databases is very difficult. You have to search multiple databases at a time to reach like a full set of information. And I know there are efforts being made at several pharmaceutical companies that are implementing this RAG strategy with multimodal data searching and insight generation. And we can, of course, do biomarker quantification and automatic lesion detection. And when we talk about diagnostics, we can have something that actually doesn't seem that controversial. Automated case prioritization. Let's say an algorithm runs on a set of slides and prioritizes the ones that need to go out earlier or that are positive. Or, I mean, that's also an interesting thing because, like, why would you prioritize the positive ones if the people who have negative ones also want to know very fast if it's negative? But the answer to this one was, okay, we have usually more cognitive power in the morning, so maybe more difficult cases, which usually are the positive cases, should be prioritized. And then, you still do everything within one day and everybody gets their results at the same time. But you are working on the most difficult things when your mind is has the prime hours of functioning. Computer-aided diagnostics and prediction of molecular tissue properties in the images. We covered that in the previous part already. The last thing before we do Q&A, the 6 out of 7 concepts, and this is just to illustrate something. So image analysis is also a blanket term. You basically analyze images. How specific is that? Not too specific, right? And I have a very good third comment from Enisa that she is doing instance segmentation to achieve precise quantification breast cells, right? Super specific. This is what I do for my image analysis. And this is the level of specificity we kind of need to communicate clearly. Let me show you this example with my giraffes. These are giraffes that I photographed myself in Disney, in Florida, in Animal Kingdom. So when you look at those giraffes on this first picture, you see like, okay, maybe it's not big enough, but it's from the book. So if you have the book, you will see a better version of this picture. But basically, you can appreciate that there's one giraffe, there's another one, and there's another one. And, you know, this one is very far, and this one is not that far, and this one is super close. And you have seen it immediately without any problems. But and the computers divide it into, okay, I want to just detect these giraffes. And then we put a bounding box, a box around the giraffe. So this one is in a box, right? And there's another bounding box around the small one and another one around the middle one. And here it has been detected. So if you just need to detect cells, you can use this approach. Why wouldn't you go for a more fancy approach? If you only need to detect these cells and count them, this is a computationally cheaper approach. It's going to be faster. It's going to use less of your computational power, and you don't have to overdo it, even though natural thing for people is I see it and I know what it is, right? Let's say we needed to quantify how much area on these pictures those giraffes occupy. Do I need to know where each of those giraffes is? No, I could just make like a red on red is not optimal, but I can basically like draw a boundary around all of them. And let's assume I actually like did it around the legs as well. And all this area is going to be my giraffe area, right? So if I need an area of something and I don't need to count it, and the only metric is area, then I'm going to go for semantic segmentation. This is how it's called. And if I want everything, if I want to detect the objects, and if I want to segment them, each of them, like have giraffe 1, 2, and 3, the red one, yellow, and the pink one, then I'm going to go for instance segmentation. And these are the computer vision terms associated with solving particular pathology problem. With detecting cells, and this example here, those cells are actually not cells. These are Alzheimer plaques in a brain sample stained with IHC. And so you can count them, but maybe one is bigger and the other is smaller. So maybe the counting is not really giving you enough information. You can also just delineate their area, and maybe that's enough information. Maybe it has been shown that the area corresponds to something, but maybe you want to have everything, and maybe you want to know the area, the exact number, and then check like how many big ones are there and how many little ones, and do the little ones matter or not, and things like that. Then you have to go for instance segmentation. This is like a micro example, what I want you to take away for AI. So is image analysis good enough or not? It's fantastic. No, it's terrible. Both statements are correct. It depends what are you using it for, what kind of method are you using, and then only how well it performs. We kind of need to be super specific, be able to judge, which we have to judge. We have to judge, and I'm going to be starring. I already see some good comments. Janet, I have you. So yeah, we have to know the use case, know the tool that we're supposed to use it, because if we're going to be doing semantic segmentation, then we start counting those plaques. These are not good numbers because you have merging of plaques. So that's the wrong tool. It's like, I don't know, using your fork for the soup. With that, I officially start Q&A. We have less than half an hour for Q&A. And while you guys are asking questions, if somebody does not have the book yet, put it big. Let me know if this code is actually working. If somebody can scan with their phone, and you should be able to download the book through this code. So just if anybody does that right now, let me know by code working, and then I will know. So let's start. We could start by optimizing the workflow with AI, but it's still difficult for us to have the necessary technology. Yes. So that's another question. I agree. And yeah, if I understand that not everybody can stay all the time. Thank you so much for joining, Brittany. Going back to this question, Janet's question. Yes, not everybody has the necessary technology, and I don't have a solution to that. But there are different, and I've had somebody reach out to me saying that, oh no, in my region, this is still so far-fetched. We don't have whole slide images. We don't have something else. And yes, there are places. I mean, it doesn't have to be a different country. It can be in the US or wherever, right? You have one practice that has gone fully digital and the other one didn't do anything digitally. So one thing that is kind of an example, let's try to figure out workarounds and let's try to figure out leverages even when we don't have access to the full pipeline is, for example, image analysis on static images. You don't need cold slide images to do image analysis. There are solutions that there are models available that run on static images that you can take from a microscope camera. You have companies that have microscope cameras that partner with AI companies that can deploy it while you're looking at it under your microscope, and then on the screen next to you, there's this algorithm running. So for example, Smart in Media, I recently saw their Chi-67 counting capability. And then there's also another company, Augmentics, that I know that they were working on something. This is like a module in between your eyepieces and your objectives that also kind of does it real time, and you don't have to count things manually. So I hope that answers. Let me know if you have I'm going to be scrolling and checking. But yeah, give me questions. Give me things that were not clear yet, that maybe you don't believe, but somebody told you and you didn't know how to answer, and I can maybe suggest a different point of view. And if you are still here, and if you can give this live stream a like on whichever platform you are dialing in from, that would mean a lot to me, because then more people are going to be seeing it. Okay, so I'm going to show something that is not a question, but Dr. Kim is struggling to find internship or volunteer opportunity to work with companies who are currently involved in training of AI or machine learning models to improve diagnostics in pathology. Do you know any firms where I could look for such companies to apply, please? So if anybody from such company is interested, feel free to reach out on LinkedIn. And Dr. Kim, I'm going to get back to you about anything else that I know about getting involved later. And there's another question. You can give me all the questions. It doesn't need to be strictly related to the talk. There's another question. I'm looking for a database with high resolution images of toxicology pathology studies, but haven't found it yet. Well, have not found it yet, Masoud. So I'm a toxicology pathologist as well. I'm sorry not to be able to answer your questions. So you probably are aware of the partnership that Charles River has with Deciphex. They have been doing this internally, leveraging they have been developing models, but this was an internal database. I am not aware of any ToxPath available database, but there is an initiative ongoing. I was mentioning this last time, Big Picture, but this is not going to be something that is for free and openly available. This is something where you will be able to apply, and they are in their year 3 or 4 out of 6 years of generating this database, and ToxPath database of images is part of that. Okay, I am having here some questions. So how can we start to optimize the workflow with AI? So to answer this question, I need more specifics. So examples that I gave, and feel free, Ray, to drop consecutive comments as I speak. So the examples to optimize workflow is the prioritization of cases. So there would be an algorithm running on scanned images that prioritizes cases. Then there is automatic quality control of images. There can be things happening while the images are being scanned. So this quality control for digital images can actually happen while images are being scanned in the scanner. Other things is maybe automatic assigning of cases to a specialist, depending which part of the workflow you want to address with AI. Let me know which part of the workflow, maybe I'll have some idea. And then Christina is saying one problem is that the companies will not take over the responsibility for the diagnosis. So if it is still the pathologist's responsibility, they will of course want to review the slide. Yes, which they should. And so what kind of application are you talking about? Because I'm not sure of any applications that kind of allow the pathologist not to look at the slide, exactly for this very reason, because the pathologist is signing off on the case. The pathologist is signing off on the study. So the company is giving you a tool, and you see if this tool is good enough. So like a company that produces hammers is not really responsible for you doing damage to your finger with this hammer, right? You need to know how to use it. And that's how I see it. And that's why I like to know how the tools work. I like to see the performance. I like to see the performance over time so that I can be confident that this is actually helping me and not helping me. I hope that makes sense. And feel free to give follow-up comments. I see another one. Christina, I see the space for digital pathology in triage and counting heavy stains, but not for diagnosis. Why not for diagnosis? So you don't like the computer-aided diagnosis approach? I mean, you can not like it. That's okay. So I don't believe in the AI replacing pathologists. This is not something I subscribe to. I do subscribe to AI helping pathologists. Triage is going to help. Highlighting foci, if the algorithm performs well enough, is going to help as well. It directs you to things that you can then aid. In that case, I do believe in diagnostic applications, but not something like it has to be an aid where there is still enough cognitive power of the pathologist to actually sign off of it on it and not be biased. And I totally agree that this can also introduce bias. From what I have seen from the publications, the level of like the things that the AI is helping with is pretty binary. Is there something or is there not? It's counting. So for example, a diagnostic application would be counting Ki-67 currently in, I don't know in how many fields of view, but for breast cancer diagnostics, you need to count at least 500 cells in a field of view. If I can not count them and have an AI count them and then see if the markups match, that's a good diagnostic help for me. So yeah, Christina, you're asking what's the benefit. So 7% more accuracy in the Page AI study. That was, for example, the benefit. If that's good enough or not, that's, depending if that's enough for you. Maybe it's not. Now, there is a comment from Christian. We need to see remote biopsies to make money. That is the way in which pathologists today can take advantage of digital. Do you know anything about it or any international company that needs diagnosis from pathologists? There are, I don't know about international companies. I know about applications. Thank you so much, Christina, also for the good discussion. I love it. But going back to Christians, I know applications abroad diagnostics. So for example, remote consultation. You can consult from abroad on digital slide. I know applications of companies hiring remote pathologists, but so whenever it's coming to hiring somebody from a different country, regardless of the country, and USA is the 6th country I've lived in, regardless whether you like work from abroad, there are regulations involved. So it's not like, oh, now we can, other than European Union, but for me, at least as a European Union citizen, it was easy to go and work in Germany and in Spain. But basically, there's immigration involved. So there are companies, and I've actually seen this being advertised on LinkedIn, but I don't think it was for diagnostic applications. This was for annotation. There was like a part-time, and I think Dr. Kim was asking about that. So there was a part-time position for annotating pathology images, and the requirements was an MD pathologist. So there are options. Anything else? Don't forget to let me know if you want the ethics presentation. I don't see anybody who tried the code, so I don't know. I hope it's working. I can try it on my own. I think it is. Yes, it's working. Okay, perfect. So yes, I'm here for you. We still have 10 minutes. Let's discuss ethics. Okay, good. People want the ethics. And I see, Kristen, you're interested in moving to New Zealand. I know they have a program for health professionals where it's actually from the immigration standpoint, not that difficult to go there. Let me know if you have any more questions regarding anything digital pathology, if there are any other topics. So I wanted to ask you something. So I'm thinking of exploring something that I found on LinkedIn. It's called audio events. Why am I trying to explore this? This is something where I can go live and talk to you and we can actually have a conversation. It's audio only, and I see that the code is working. Perfect. Thank you so much, Samuel. There is, so instead of me giving you a presentation and you having to watch it on video, it's something that you can just join as audio only. Would you be interested in me hosting an audio event? Give me an audio in the comments if you're still listening to it, if you would like to join an audio event. For me, I want to start doing this because it's a lower, like easier for me to just show up for you more often and to have these discussions. But let me know if you would like that. Well, you would like audio? Give me audio in the comments. LinkedIn audio events. Then you would get a notification probably per email if you're on my mailing list and have a good question. So, and then invitation from LinkedIn. Let me know if you would like audio event, just a listen in thing where you can actually like be driving and not watching me. Question: brief insights about data protection regarding use of AI solutions cloud-based. So do you mean if data is protected in the cloud? Is that the question? So if you want to provide cloud solutions for medical purposes here in the US, you need to be HIPAA compliant. So you need to comply with this regulation of not disclosing any identifiable data. And I know that the companies that are actually having their images and deploying algorithms in the cloud do comply with, if it's for medical purposes, they need to comply, otherwise it cannot be used for medical purposes. So I hope that answers the question. If not, let me know in a subsequent comment. So basically, whether regulators accept something being done in the cloud or not is another question. So for example, in Europe, it's not that in Europe, the GDPR regulation, and there is a new AI risk stratification regulation. These things kind of have to be complied with. And in Europe, for example, for different regulatory bodies, it is necessary to be able to audit the location where a server with the data is located. So if you have cloud-based computing and the data is in the cloud, the data can actually be in a server that's outside of the country, and that is not acceptable for your regulators. So it depends on the country. And if that's not acceptable for your regulators, then you cannot do it. Then you have to, for example, have your own server. Or like you can do cloud, but you have to have a dedicated server that you're renting in a particular space. When a regulator wants to inspect, you have to go to that particular server. Okay, and I see people are interested in audio events. Let me know if you like the audio events. Tell me what you didn't like about this presentation. What do you think is like totally useless? And for those who need to leave, thank you so much for joining. I appreciate you staying till the end. This means a lot to me. I know that we are bombarded with different types of information, and I very much appreciate you joining me here on those presentations. I'm planning to do one more next week. Might be the ethics one. So I'm going to kind of deviate, because several people wanted the ethics one, from the Digital Pathology one-on-one book series, or any of the remaining chapters. One is very TalkSpot specific, so I might leave this one till the end and just, I'm going to let you all know if you want to learn more about TalkSpot. That's going to be a good presentation. It's very underrepresented and under talk about the specialty of pathology. Then there's one about the history of digital pathology and general digitization concepts. And one more chapter that I'm now, or the ethics. You can let me know if you're watching the replay, then you can let me know which is your preference, either book or ethics for next week. I'm going to still stay here for the couple of minutes that are left for our Q&A. Maybe some questions are going to sneak in. And yeah, you're welcome, Sumed. I'm glad this was a helpful answer. What else I'm going to do? There's going to be a replay. So everybody who needs to leave, you will get a replay. And if you would want to share it with somebody, I will have this replay available for everyone on YouTube. So if there's anybody you think would benefit from this content and you can share it with them, I would very, very much appreciate. And I'm also going to make audio content out of this, like I did from the last webinar. So if you want to have a quick audio recap of what we were talking about, with maybe a little bit of editing, cutting out my ums and ums and the pauses that I'm making, then go ahead and visit the Digital Pathology podcast page. And thank you so much for those very, very nice words that the presentation was great and good introduction to AI in pathology. Were you surprised with anything? Did you already know about all these things? Did it make you look at it from a different angle, or was it just a recap? Okay, I'm going to do the ethics seminar definitely either next week or the week after. After next week, I'm going to be in Poland. So I'm not sure if I'm going to be able to do the live streams, but I already have videos prepared for you on YouTube. So definitely you can see me there and interact there in the comments. And if we don't have any questions, then I thank you so much for staying till the end. It was a long presentation. If anything comes to your mind after this presentation, something pops up in your head, you can go back to the recording that I'm going to be sharing with you and put a comment there. And okay, there's a request for natural language, please. There actually, I did give a presentation about ChatGPT where I was explaining natural language in it. So that's on YouTube, but I can do an updated one because that was like, I don't know, over half a year ago, and so many has changed in that space. And then I can also incorporate the data from Andrew's podcast. The literature has been more and more compelling, though it remains to be seen what the interface is between pathology training and AI deployment as a whole. Definitely. Yeah. With every single application. There's no blanket statement, yes, AI, no AI. It's the same like scrutiny for every single application. It's let's think about it as each of these is a separate medical device. And for every medical device, you need to show the supporting data to get your clearance or to get your approval. So it's the same with AI. It's not like all AI, it's this particular application of AI that has enough supporting data. Thank you so much. And now I'm going to be jumping to the private Q&A with the Digital Pathology Club members. So if next time you want to join the club, you will be able to find the link when you get the book. This is like a more closed group, a paid membership that I'm hosting. And I hope to see you there one day. And if not, then see you on YouTube and all the other platforms. Thank you so much. Obviously, on the podcast, there is no place for comments, but feel free to send me messages on LinkedIn. If you're on my email list, go ahead and shoot me an email or leave comments on any social media platform that you're following. And I'm going to be collecting all those questions. And maybe that's going to be a fantastic fuel for the audio events. Stay tuned for the next audio event and join me there. And I talk to you in the next episode.